In this video, I'll be going through the YTSS Prelim 2022, question 11. So for question 11, mainly is on your EMI, the last chapter about alternating current generator. So for part I, I'm asking you to identify component X. So component X is this ring over here. Yeah, and the technical name is basically slip ring. Some of you are telling me slip ring commutator. I think I have made that clarification for those of you in my class. I make the mistake in my notes previously, and I have updated you. For AC generator, the ring is just called slip ring. For DC motor, then it is called split ring commutator, 3 words. In part 2, I'm asking you to label the direction of the induced current at A and B. So you need to respect the question and you draw the direction of current at A and B. So here you need to use your Fleming's right hand rule, and your hand should be orientated like this. If you have problems orientating your right hand, please come and see me so that I can help you. I have given you a quick sketch over here. I'm not sure if you can align your right hand to it, but basically your magnetic field is over here, applied force, and then you will be able to find out the direction of current on this particular wire. So this photograph is taken for this wire over here, okay, the wire nearer to the North Pole. And by linking up all the pieces, so here I will show you how it look like. You can see that once you deduce the direction of current on the left side of the coil, you can trace it, and you can see that it will exit slip ring X, and then it will come out from B over there. Yeah, so again, if you couldn't figure out how it works, please come forward, ask me, and I will help you with it. In part 3, basically I am just checking whether you have memorized your content knowledge on how a current gets induced. So I'm asking you, why is there a current induced when you apply a force? So I only accept the answer that we train you in class. You need to tell me that the keyword, the object, which is the coil, that is the conductor, that's our subject, and I want to see the keyword experience, right? Then I need to know that it is a changing magnetic flux. So it is not a change, it is changing because you are rotating. It is not increase or decrease because you are rotating, it is always changing. So changing magnetic flux, and I expect to see these exact words and phrasing linking to the source of magnetism. In this case is the magnet, and I need you to tell me what law, and in this case is Faraday's law. And because you quote Faraday's law says that it is an EMF that is induced. So you need to tell me EMF is induced, and finally a current is induced. Next, I'm asking you why do you feel that as you rotate the coil you will experience opposing force, right? And this can be explained by two ways. The first way is that you can quote your Lenz's law, and you can tell me that because of Lenz's law, what happened is that the induced current that is flowing in the coil will actually produce a magnetic effect, and this effect will interact with the magnetic field from the magnet, and it will oppose the rotation. So because I only give you like 3 answer line, I expect like a short and sweet answer. You don't need to go into very detail. Or if you do not want to quote Lenz's law, you can also tell me that, since there's an induced current, whenever there's a current, there will be an accompanying magnetic field. So when you have an induced current, the induced current will produce its very own magnetic field, and this magnetic field will interact with the magnetic field from the magnet, and as a result, it produces a resistive force. Well, you can explain in either way, and I will give you the full score. Now for part B, I'm actually quite disappointed, especially for those who got it completely wrong, because then it showed me that you didn't really do the SLS while I'm on my work attachment. So down here, those of you who get 0 is because you thought that the gain over here tells you the voltage that the CRO is experiencing. No, the gain over here and the time base over here, right, is basically telling you what is one box. So here the gain says 0.4 volt division, right? It's telling you that every box represents 0.5 volt, 0.4 volt. And this time base, right, is telling you that on the x-axis, every division is basically 0.5 milliseconds. Yeah, that's all it tells you, nothing else. Same thing for the secondary coil. What does this gain means? Well, it's trying to tell you that one box over here is 2 volt, and that one box over here, right down here, is 0.5 milliseconds. So if you want to go and find out what is the turn ratio, by the way, turn ratio is also a fixed definition kind of ratio. You have to place the secondary coil on top and then the primary coil at the denominator position, right? So since we know that in your transformer question, NS over MP gives you VS over VP, so you need to go back to the CRO diagram. Your VS is given by this part. This is the amplitude you measure from the center line. So this tells you that the VP, your VP, if you look at this, is 0.4. And if you want to find your VS, is from here to here. So this is your VS, this is your VP, and so it occupied 1 square, 2 square, which means that it is 2 times 2 volt, right? Because every 1 square is 2 volt, so the amplitude here is 2 square. So once you work it out, you will find that it is 4 over 0.4, and you will work out that your turn ratio is actually 10, right? It is very simple, right? It's whether you have prepared for it or revised. Those of you who got it wrong, I can see that you are just trying your best to guess. But I admire your will to try, okay? Don't leave it blank, always try. Okay, next thing is to find the frequency of this alternating current. So to find the frequency, if you read the graph directly, you can't find the frequency, but you can see that within 1 square, 2 square, 3 square, 4 square, you actually can generate one full wave. So basically from the graph, you can see that your period is given by 0.5 milliseconds multiplied by 4 division, right? So you will get a period of 2 millisecond. You need to turn this into your SI unit, which is 2 multiplied by 10 to the power of minus 3, right? Then after that, if you want to find the frequency, it's just 1 divided by the period. Okay, you go and work it out. If I remember correctly, it is 500 hertz. If I remember correctly, yeah, you go and check. Okay, please check. Okay, then for the last question, I'm asking you why isn't the fan working? And down here, especially in your section B, sometimes you will find the answer in the beginning. So down here, I'm not sure if I can still move this guy over here because I think I cover one of the main thing. Yeah. So you can see here the fan. Down here, a fan is actually operated by a simple DC circuit. So even if you connect a AC generator to a step-up transformer and connect it to a fan, what happens is that the AC source, after you run it through the transformer, is still going to give you an alternating current. And if you have an alternating current, you cannot turn a DC motor, right? So down here, the ideal answer that I'm looking out for is that the student should recognize that a transformer can only work with an AC source. An AC generator is going to produce an AC source, and when you have an alternating current, it won't work with a direct current motor. So I'm looking out for this answer. If you want to fix it, you need to add a diode, right? Like how we power up our DC motor fan in our room or in our classroom. Actually, from the socket, it has to go through a diode first. A diode basically change an AC current into a direct current, a DC current. Yeah. So that is the ideal answer. However, we also accept some of you saying that, oh, maybe the DC motor, the coil is at a vertical position and so there's no moment generated. Okay, I give you benefit of the doubt, I give it to you. Okay, but the ideal answer should be that. So down here in this question, I hope what you gather is how to properly use your Fleming's right hand rule, how to properly explain why a current is induced when a conductor is rotated, how opposing resistive force is generated by the induced current formed by Faraday's law. How do you read CRO? Yep, that's all. If you have any further question, do approach me very quickly before you graduate. And if you